Reflections and symmetry. I'm actually going to take a look at symmetry first, and symmetry is actually easiest to show with a few pictures. By symmetry in these pictures, I'm really talking about a line of symmetry. So if I've got a nice looking rectangle, no, that's not perfect, but a nice looking rectangle, a line of symmetry is where on one side of that line it's the exact mirror image as on the other side. And some people say things like the human face are symmetric. If you cut right down the middle of your face, it should be or is exactly the same on one side as the other. And that's basically what I'm doing here. So this blue line here indicates what we call a line of symmetry. And that's not the only line of symmetry where there's an exact reflection on one side as on the other side. There is another one that I'll draw in red here that goes across in this direction. So now the bottom part would be reflected exactly the same and appear on the top. For some objects there's quite a few lines of symmetry. For other objects there's one or none. And one of the objects that one of the objectives that you'll be doing in the practice will be to take a look at objects and figure out how many lines of symmetry and where those lines of symmetry are. So I'll show you a couple more. If we've got a nice isosceles triangle where these two sides are equal, there turns out to be a nice line of symmetry that cuts right down the middle, so that if you took one side it would be perfectly reflected across the other side. And with some weird objects, maybe I've got something that looks like this. I'm aiming to get a nice, again, line of symmetry right down the middle. Maybe if you take a look at this one from the side, maybe it looks a little bit more like a little fish, and this is the tail, and maybe it should have had some fins, whatever. As long as it's exactly the same on one side as it is on the other side, pretty close to exact on that one, then that dotted green line down the middle is a line of symmetry. And I'll ask you questions like how many lines of symmetry are there in some simple objects, and you might even want to think about how many lines of symmetry there are in some really simple objects like a circle. Well, you can cut it this way and that way and this way, and I think there's quite a few. Okay, let's move on. In this section I also want to talk about reflections. So a reflection is a transformation that flips an object over one of these lines of symmetry. Instead of really calling it a line of symmetry, we really just call it a line of reflection. So if you start off with some kind of an object, and I'll make this kind of look like a letter E, and you've got some fairly distinct points, it's nice to work with that, and you've got a line, and this is the line of reflection, and I'll try and carefully draw it straight up and down like this. Then to reflect this object, these can appear over here somewhere, and there's a rough sketch of where it is. I want to be a lot more careful, so let's erase that one. And how do we actually find out where it is on the other side? Well, we do that by following this rule. The distances of any points P and P prime, and P is on the original image, P is on the original object, and P prime is on the image of that object across the reflection line. They're the same distance. So the first thing is that they have to be the same. The distance has to be the same across the reflection line. And the second part is that they have to be at 90 degrees to that reflection line. So if this is point P, then the distance to the reflection line and at 90 degrees to that reflection line is shown with that red dotted line. And if I go and take a ruler out and I measure this distance, then I can just take my ruler and also measure the distance on the other side, and that's where P prime will be. So these two distances here and here, the distance here and this distance here, will be exactly the same, and it's got to be at 90 degrees. So you need to have a ruler to be able to do this. You cannot just estimate, and you also need to make sure that you line up the end of your ruler so that the 90-degree part that's right at the end will help you really figure out which direction you're going when you work with these movements, these transformations of these points. And then all you do is you say, okay, now I've got that point, now let's go pick another point to do, and I'll just do it in a different color. So this now will be my P, and now I measure that point to the reflection line at 90, and I go off and I get P prime here. And when I start to draw this image, I know that those 2 points had to connect. And then I just continue to do that. So I measure, and I just do this very carefully, and I measure on this side, and I do that very carefully, and I measure on this side these 2 points, and I measure them on this side, whoops, very carefully, and I play connect the dots, and I have a nice shape. When I take away all of my other work, I have a nice shape that is a reflection of the original shape across that reflecting line. So you'll do those measurements without actually having to draw, and you'll of course be much more accurate than I was with that sketch, but you'll go through that. But it is very important that you measure with a ruler the distances, and that you make sure that it's exactly at 90 degrees. And that'll become really crucial when you work with objects that are, these objects look like they were kind of flat or perpendicular. When you work with more complicated objects where things are a little bit skewed, or you work with reflecting lines that aren't perfectly straight. How do you reflect across this line? Well, you take points and you go at 90 degrees, and that's where the new top of that smiley face is. And you just keep creating new points and making sure that these are 90 degrees and the same distance away, and you will slowly develop where that smiley face should be, and you take more points and you measure where they have to be, and eventually you'll get some of these eyes, and those eyes might not be in the exact direction that I want them in. I think they're going to actually be a little bit more like this, and that will be the reflection line, and the way that you will find things that are a little bit more complicated. So you do definitely need to be careful with this section as well. Okay, let's take a look at one more thing, and that's called a tessellation. And this is now moving us into a little bit of art as well. So here's what a tessellation is. And a tessellation is a repeated shape or shapes that completely cover a surface. So the white area on the bottom of the screen here is a surface, and I could just draw like tons of squares all connected. It's kind of boring. And I could just keep tiling this in these directions, and eventually I could cover everything with a square, all of this surface with a square. So a square would be a really boring example of a tessellation. I could also do it with triangles, and there's a few different ways. I could cover the triangles maybe like this, and I just could keep doing it basically forever, and I would completely cover a surface with triangles. You can do it with lots of different shapes, but they're shapes that just won't work very well, like circles, not by themselves because you've got this little piece in the middle. But if you have circles with those exact same pieces in the middle, which are kind of a weird shape, you can actually tile something with the circle plus that shaded in part as well. So there's lots of different ways of tiling a surface, and that's essentially what a tessellation is. So, you know, the next time you are in a place that's got tiles, your bathroom or a shower or somewhere like that, maybe your kitchen, the splashboards on the back of a kitchen often, take a look and see how they've been tiled. A lot of times it's kind of boring, it's just squares, but there are some really neat patterns of tessellations. Let me see if I can show you a couple. And the easiest way to do that is to just go and see if we can find some cool looking tessellations. Oh, I actually spelled it wrong. It's double S double L, so make sure you make that correction as well. You can see immediately there's some really cool tessellations on here. There's a definition here on Wikipedia if you want to take a look at that. You can do that. I'm actually going to go into Google Images and take a look at some tessellations, and you can see like here's a star and a diamond type of one. Here's one that to me kind of looks like a bunch of birds, and actually there's a famous artist named M.C. Escher who's done some really cool work with tessellations, and if you take a look at this in a little more detail, this pattern is actually a bunch of horses overlapping, and I'm sure he's done a ton of other really cool stuff. I think there's some with birds, some with lizards, and a few other things in here. MC Escher's definitely got quite a few things. If I go back to simple ones, you can see some of those triangle ones and circle square ones. There's some neat software programs that allow you to edit one side of basically a rectangle, and it automatically changes the other one, and so you can actually design your own tessellations as well. All sorts of different things have been included. Jigsaw puzzle type tessellations, these kind of artistic tessellations, kind of more 3D tessellations. What I'm really talking about is ones that cover a flat surface, and you can get quite artistic with some of these tessellations. So there's some examples, and if you're in art class, and this is actually a real area where art and math definitely converge.